Hello and welcome. My name is Vukile. Today we're going to start on this series where I'm going to give you a general arrangement or the general arrangement of a power system. And it's pretty simple. I put a diagram on the board there, and I just wanted to have a look at that as I explain it. Okay, so there we go. First up, we have a power station where in this box here, in that box, the power is generated here and at a certain voltage and certain current. Okay, so your power is equal to the current times voltage. Okay, that's what you generate in the power station. So you generate it at a certain voltage. In this case, I've just chosen 33 kV or 33 kilovolts. This is 33,000 volts generated there, then fed into some step-up transformer, which is this box here, and then the power is stepped up from 33 kV to 330 kilovolts or 330,000 volts. Okay, and then it's transmitted through a transmission line. These are gantries for the lines, and then these are structures, this and that structures for the lines to then the line transmits that voltage there to this other end here. This is the receiving end, and that receiving end there is another transformer which steps down the voltage from 330 kV to 132 kV. After the voltage has been stepped down, it is fed into this network down here where there is another transformer, and this transformer, actually that transformer there, we'll just give it transforms from 132 to 11 kV. So it transforms to that, and then you can immediately there on either on this one or the 132 kV side, you can feed customers. There are customers who want power at 132 kV volts, 132 kV level. Sorry, and these are industrial customers. Like smelters or those big customers, and the other customers are fed from this substation here, which is 132 kV to 11 on the 11 kV side. You can feed them there. They just take 11 kV lines or feeders. Lines are called feeders, and feeds into their industrial area, where they can step down the power, step it up according to their needs. So that substation there would be their own substation. It has nothing to do with the utility that supplies power. They can do what they want to do there with their power. And down here you can have an 11 kV to 415 volts, and then step down to, which means 11 kV has been stepped down to 415 volts. You can feed your domestic customers or your commercial customers. Some commercial customers might actually want power at some higher voltage. They might actually, especially the ones that are in the CBD areas, they might have their own substations in their own building, because their own building might be a big one, a big building that consumes a lot of power. So they might need power at a higher voltage. So you might actually give them at 11 kV or at 6.6 kV or 3.3 kV, depending on their size there. So this is the general arrangement of a power system. So just to give that names, this area here where the power is generated is called generation, up to this 33 kV into that transformer there. They have to give each other boundaries according to the policies in the utility. And then these voltages are very high, called transmission. This is transmission, transmission. So generation, transmission, and from 132 kV down to 400 volts, 415 volts, it's actually distribution. You know, distribution. This whole thing is distribution. So that's what we have. So we have distribution, and these are customers or consumers of the power. So those are the stages through which power goes. Thank you very much for watching this. My name is Vukile. In the next programs, we would actually want to examine closely what happens in these areas, in the generation area, in the transmission area, in the distribution area. We will break down the components in each box, in each area, so that we get to understand what happens when power is sent. Thank you very much. I'll meet you in the next program, and have fun with these programs. Cheers.